Well, hello everyone and welcome. Today's 5th of June, which is World Environment Day, and we've got the second instalment of our pest management workshop series today. As you can see, we're inside now, so we're in the classroom at the Randwick Community Centre, which is on Gadigal and Bidjigal land. I'd like to pay my respects to elders past, present and emerging. I'm Julian Lee, I'm the Sustainability Education Officer here at Randwick Council. Steve Batley from Sydney Organic Gardens, our permaculture expert, landscape architect, and yeah, very knowledgeable guy, gardener. And Barb, who's behind the camera, she can put her fingers in front, one of our wonderful PermaBees who's been coming down every single week, even in the rain, to help us do this. Thank you very much, Barb. So, a bit of a different format. This is the second in a three-part series, and last week Steve took us through the fascinating world of good bugs and bad bugs and showed that a balance is needed in order for nature to do the work for us. This week we're going to be looking at pest management from the point of view of soil health and what the leaves in a plant tell us about what's going on in the soil. So if plants are healthy, generally speaking, they are far less likely to be attacked by pests. When I was up at the farm and I was growing vegetables for a living, I noticed in particular there was tatsoi, like a bok choy, and there were two of them growing side by side, and one of them was being completely attacked by caterpillars, and the other plant right next to it wasn't being attacked. And I'd heard this, and I thought I've got the opportunity to observe and see whether this theory was correct, that a healthy plant can basically repel pests and an unhealthy one doesn't. And what happened was the caterpillars just completely destroyed the other plant, the healthy plant next to it, was completely left alone. And the caterpillars turned into moths and disappeared, didn't lay eggs on the plant next to it. So for me, it's anecdotal, or it wasn't anecdotal, it's a case study, but it really showed to me that idea had some validity to it. It was amazing.
Yeah, I've seen that too.
Yeah. Yeah,
it's two plants, exactly the same type of plant next to each other. One just gets mashed by insects and the other one doesn't.
Yeah. So part of the science behind that is that unhealthy plants actually put out a chemical signal which attracts insects, because nature basically doesn't want them there. They're not suited to that environment, and the insect's job is to come in and clean them up and return the nutrients back into the ground. Whereas a healthy plant isn't putting out that chemical, and it's apparently the sugar content is also different, makes them sort of much less palatable or even undigestible for insects. And so there's, they've got an equivalent of a plant immune system. So it's really cool. The thing we've got to keep in mind is that when we're growing vegetables in Australia, we need to create conditions different to the native environment. So we are trying to change quite a lot of the soil conditions to suit those plants. And if we don't meet the needs of the vegetables, then they can get sick and attacked by pests, which, given all the questions we've been receiving, it seems like a lot of us are struggling with that, and it's a pretty common thing to happen. So the good news is, if the soil's missing something that the plant needs, it'll show up in the leaves. We're able to read each other, well, you're looking a bit peakish, you look like you got a bit of fever, we're used to reading symptoms in humans. Well, leaves are actually telling us this all the time. Plants are telling us this all the time too. And one of the really obvious ways is in the leaves. And so you don't actually need to get a soil test. And today we're going to do a little primer on how to read the leaves to diagnose what's going on in the soil. The big question is, what will you do once you know a plant is showing a deficiency, and it's on its way to being sick? The prevalent way of thinking is to plug the gap. If a plant's missing iron, for example, then what do? We give it some iron. And we do this with humans too, all the vitamin pills. So while this sounds pretty straightforward, it doesn't take into account that plants don't live in isolation. So plants are growing in soil, which if it's healthy, is full of grillions of bacteria, fungi, insects, and hopefully worms as well. A myriad of things. And they're all interconnected in really vital ways. Plants secrete all sorts of goodies into the soil through their roots that feed the bacteria and the fungi. In return, the bacteria and the fungi in the soil are giving back micronutrients to the plants that they wouldn't actually be able to get on their own. So it's a two-way street. Now worms, which we all know play a critical role in aerating the soil, allowing water to get into the soil, storing water in the soil, and providing their really rich humus amongst many things, eat the soil bacteria. So you're starting to see a chain in there. So going back to the question, what are we going to do if we notice a deficiency? If you feed a plant directly, for example, with fertilizers, or in this case, an iron additive, you actually break the chain. You eliminate the need for plants to feed the soil bacteria, which in turn feed the worms. And you disrupt a whole chain of interconnectedness. And what that ultimately results in, over a long period of time, is soil degradation. And you get locked into a cycle of chemical dependency. As plants growing in poor soil, they're not as healthy and more prone to pest attack. So if you use fertilizers, plants no longer feed the soil bacteria, which would have fed them back micronutrients to keep them healthy. And if you use pesticides to get rid of your insects, then this also, it kills living things, kills soil bacteria, which then also reduces the health of the soil and the plants, and round and round it goes in a downward spiral. But don't worry, nature can show us the way, and it's actually a much simpler story when you tell it in this direction. So, if you've been with us for a while, you'll have heard Steve say that diversity. Diverse plants means a diverse range of root secretions into the soil, a diverse buffet for the soil bacteria to feed on. And so it supports a lot of different bacteria, a lot of different fungi if you've got diversity in plants. That in turn means a big buffet for the worms. And overall, what's happening is you're getting a lot of micronutrients available back to the plants, which keeps them healthy, which means that they're resistant to pest attack, talking right at the beginning, and therefore don't require those pesticides and all the other chemicals that go along with it. So keeping all that in mind, I'd like you to compare the two different approaches that can be taken for each of the deficiencies that we'll be going through in just a moment. But as that's a big chunk of information, just opening up to any questions.
Can you hear me?
You can yell. Yeah, we can hear you. Is that Kerry? No, we heard somebody begin to ask something. So you'll need to take yourself off mute.
I think I've muted everybody.
That's okay, they can take themselves off mute. Yep. Barb, you had a question? No, you've got to yell out to hear. Yep.
You said we have, because we're growing vegetables and we have to move away from the native environment. My question is, why do we have to move away from the native environment? Why can't we grow native vegetables?
Yes, well, I guess if we were eating bush tucker type of foods, indigenous foods, then they're perfectly adapted to the soil here in the places that they're grown, and you wouldn't need to change the soil in any way at all. But we like our zucchinis.
Leaning towards one type of
That's right. If you want the eggplants, zucchinis, all the things that we're used to eating and cooking, then they don't grow in Australia, in most Australian soils.
So I've got a question. It's Nikki here.
Yes.
Can you grow? So I'm trying to grow plants that will attract native bees, which are obviously native plants as well as others, but lots of native plants. So how do you resolve the conflict between the soils that native plants need to thrive in and the soils that you want to grow vegetables in?
I've got an answer, but I might throw to Steve, particularly because, and it'll be a little bit of an advertisement for next term when we'll be running Gardening on the Wild Side, which is all about, growing and planning and designing for native habitats. And we've got a good garden here that actually does show the mixture of natives and non-natives.
Yeah.
Steve.
It's a really good question because most natives, most native plants don't need lots of nutrients. They've evolved in our old Australian soils that don't have a lot of the things that introduced plants need. So I guess one strategy is you just have a separate garden for your natives as for your veggies. A lot of people do that. So you have you plant your plants that don't need a lot of nutrients over here, and you plant your plants that need lots of nutrients over here. There's actually a fair bit of crossover. I don't think, I've found, and there are different native plants. So some plants that have evolved in Australia actually don't mind lots of nutrients, and they will go completely fine with lots of compost and mulch and the rich soil. So it's kind of it's really, I guess, understanding that individual particular species of plant and what it needs and what it doesn't necessarily need, and then designing according to that knowledge and that understanding. So it's not necessarily always just cut and dry, but I don't know if that helps, but it's understanding each plant's needs and then providing what they need in your ecosystem by designing them in the appropriate spot could be the solution.
Thank you.
Any other questions?
I have a question, if that's possible.
Yeah, go for it, Jan.
Yeah, thanks very much. Basically, my question is related to planting in contaminated soils or in soils that are deemed to be containing heavy metals, like in Sydney, in the West, or Melbourne, because I know that we shouldn't be planting, or correct me, right? I think I know that we shouldn't be planting vegetables directly in the soil, but in raised garden beds if we in these areas. However, I also heard that we can plant fruit trees, for example, plums or mandarins or oranges, and that the fruit actually does not carry the heavy metals that are in the soil. But I'm not 100% sure. Is there like a direct, like a divider? Like what would be your comment on that? Thanks.
I think probably the safest thing is that, the plants, pulling all those nutrients out of the soil as well as the air, that even the fruit trees would be, taking in those pollutants. So I think probably the safest thing is to not grow, plants that you're going to eat from in soils that have contaminants. But that's the simple.
Yeah, it's a really big question, a really good question for urban growers, because we're living in unfortunately a lot of our soils do have some sort of contaminants in them, and I think it's a bit of a plant specific answer. So yeah, probably almost another whole workshop on that. But I think the general rule of thumb is plants tend to take up heavy metals and things in their leaves more than the fruit. But don't sort of use that as your guide. Do your research, find an expert, get some expert advice. There are companies out there who do soil testing, and they'll write reports and they'll give recommendations based on a really deep level of knowledge. But the basic understanding is that you wouldn't grow things where you're eating the leaves in a contaminated soil, but there sometimes can be opportunities for growing fruit trees because they don't necessarily put the contaminants into the fruit, but But yeah, ask someone who really knows what they're talking about would be my.
Okay, thanks for that. Thank you.
And I just got through, apologies, I've forgotten who sent it to me, but somebody just sent me through, I think one of the universities, it's a citizen science project, where for only $20, you can get 5 soil samples tested. Might take 4 to 5 weeks before it comes back. But yeah, so that's a way of getting a test done. You can message me afterwards, or I'll try and put it up somewhere. Yeah. Any pressing questions before we move on to looking at what the leaves are telling us? Okay, so we're going to do a screen share here. Just a look of alarm on Steve's face. Okay, here we go. Can anyone not see a black and white stripy chart? Okay, so it would seem that everyone can see this. Where we're going to start is that, again, you know, just keeping in mind the different approaches that can be taken around this. And one is well, let's find out what's missing and let's plug the gap. And the other is taking a bit more of an ecological approach. But with that with that in mind, looking at this pH chart is actually a little bit important. We'll be talking about it when we go out into the garden. What you'll see there is across the top is the acidity of the soil, from very acid on the left through to very alkali on the right. And in the middle is what's generally considered the sweet spot. As you go down the chart, what you'll see is the different nutrients: nitrogen, phosphorus, just covered up, Steve, potassium, etc. as you go down. No problem, just put it off to the left. Then the black lines, the thickness of the black line represents how available that nutrient is. So if we're looking at the very top one, nitrogen, you can see when it's very acid, the line's very thin, and so nitrogen is not very available to plants, even if there's tons of it in acid soils. So that's why if you run your finger down, particularly around the 6.5, you'll see that almost everything is moderate thickness to large thickness line, which means that it's very available. Now, if you look to the left of the chart, a lot of Australian soils are acid. Also, farmers who continually apply synthetic fertilizers, they are acids. And what's happening is they're acidifying their soil. So if you then trace your finger down, you know, the 4.5 and the 5 mark, what you'll see there is that a lot of the nutrient lines thin out. And so no matter how much nutrient you put into the soil, it gets locked up in acid soils. Yes, so let's say either continually adding a lot of synthetic fertilizers acidifies the soil, or a lot of Australian soils are just acid. So keep this in mind as well, because that's quite a large effect. What we're going to do now is actually go through a bunch of different nutrient deficiencies and what they look like in leaves. After that, if you've brought a leaf, I hope you have, we'll break out into groups and you'll be able to use the chart and the information to try and help each other figure out what's going on. I've just realized I've made a programming mistake because you haven't got the chart for that room. But as you're all on computers, if you really quickly Google simple leaf deficiency chart, you'll have that available to you. Apologies, I should have sent it out ahead of time. Now let's click to the right. Click on this. And then click right. There we go. So this is the Simple Plant Deficiency Guide. And if you Google those terms, you'll get it quickly, and especially if you click under images in Google. What it does is, these are some of the really common ones: calcium, iron, nitrogen, potassium, manganese, magnesium, and phosphate. What it does there, you can see, is there's some really key distinctions that always occur. That red dotted line shows the young leaves, because there can be a difference if you're seeing discoloration in the young leaves as opposed to the old leaves. That's meaningful. And then if you also look down the right-hand side at the ones like potassium, manganese, and magnesium, and we will go through these individually, exactly where the yellowing is occurring is also really important. Is it occurring first at the tip? Is it occurring uniformly? Is it occurring in spots? And are the veins showing? So let's use this chart one by one. So just click right arrow, I think. Great. So this is blossom end rot in tomatoes. And it's got to them pretty early because they almost don't look like tomatoes, they're so pale. So this is a calcium deficiency, and it causes blossom end rot in tomatoes and a bunch of problems. In leaves, and we'll show you some in citrus later, it causes the leaves to actually end up misshapen, gnarled. Here, it can, as you can see, it completely destroys your crop. So, two different approaches.
Does that happen with zucchinis as well? Do you know? Does anyone know?
I think it does, but I think when we're seeing that rotting, it's lack of pollination. Yeah, okay. Yeah, they're not fertilized fruit.
Okay. Sorry.
Yeah, no problem. Okay, so the two different approaches. What could we do here? Calcium. One obvious thing is lime. It's a cheap product. You get just a bit of gardener's lime. It's lime is calcium carbonate. So when you add it to the soil, you're adding calcium to the soil. Brilliant. So that's one approach. Another approach would be?
Not to add lime, but well, I think on an ecosystem level, how can you provide that calcium by managing your ecosystem so that it provides the calcium for you, and you don't need to go out and buy a bag and buy a product that's been dug up from somewhere else and spend your money and all that. So is that what you are?
Yeah. Just making it so it's more conversation.
Another way to look at it is rather than putting something in to solve that particular problem or issue, what's another approach? What's a bigger picture approach that will actually solve the problem, but not necessarily cost you money or time or resources, or potentially have other damaging effects that we're not even aware of?
So feel free to add this to the chat, and you can bring up chat, or if feel free to yell out if there's not a lot of yelling out going on. So just come down here to more. Just give us 1 second while we bring up the chat window. Oh, sorry. Click on Zoom. Yep, and then bring up chat. Oh dear. Okay. Don't chat because yell out if you've got something.
Composting, would that help?
Composting?
Yes.
Yep.
Sorry.
Composting. Any other ideas?
Are there any plants that actually feed calcium back into the soil? So could you plant?
Oh, Nikki.
Oh,
you're a gem. No, you're a gem. We were having this discussion before, and we're not entirely sure whether the science is there yet to say these plants secrete put into the soil that particularly feed the bacteria and the fungi that would return calcium. So, not sure. But yeah, that sort of thinking. So the approach would be, what's Steve's favourite catchphrase?
Oh, I can't remember.
Plant wide range of diversity so that you don't necessarily need to know, but somewhere in there the synergies might be happening that feeds those things that bring the calcium back to the plant. And of course, for those that eat eggs, rather than extracting lime out of the ground, eggshells of calcium.
And maybe just to put it out there, what other sorts of shells might you find in the garden? Talk about pest management.
Pardon?
Barb's yelled out insects.
Yeah,
They're
so
exoskeletons.
snail shells?
Yeah,
Snail
snail
shells.
shells.
Hmm.
So snails have shells, which I'm guessing have lots of calcium in it. So if we get rid of all our snails, we're getting rid of all our calcium fertilizer. So, well, I think last week we talked about having a blue tongue. If you can attract a blue tongue to your garden, you know, there's your calcium supply there. Just a slightly different way of looking at it.
So everything's interconnected. Okay, do you mind pressing right? Yep. Thank you. Okay, so yellow leaves. We're looking down. This is now basically the young leaves are light green, and you can see in this picture that the older leaves are dark green, and the yellowing is pretty even across the whole plant. So that's a sign that it's a nitrogen deficiency. So again, a common approach would be to add a nitrogen-based fertilizer, you know, something like that. But what would we?
No, I think a lot of you guys know what to do to get nitrogen into the soil.
Other plants, plant leaf mulch, leaf green.
Mulch, legumes?
Green leaf, yeah.
Yeah, green leafy plants. Yep, and a lot of the legumes. Okay, next leaf, please, Steve. Okay, this one's telling you, this is a phosphorus one. I've picked tomato here, even though it doesn't show exactly the same things as the deficiency guide, because a lot of us would be wanting to grow tomatoes, and that purpling of the underside is really common. So if you see that in your tomatoes, it's a phosphorus deficiency. So Barb has asked, what's the difference between phosphorus and phosphate? Phosphorus is just the element on its own, but they're rare to find just in the environment. And phosphate is the sort of, particularly if you're buying a fertilizer, you'll get, you know, it'll come in the form of ammonium phosphate, which breaks up into the soil and releases phosphorus, but is acidic. So that's the chemical approach. Again, you know, as we've been talking about, rich composts, wide variety of plants, and again, you know, leafy greens. Is there anything else that you might add then, Steve?
No, I don't know what.
Yeah.
Plant-wise, but there's a lot of stuff that we don't know about this stuff. So yeah, it's really interesting. Lots more research to be done on how can you add phosphorus.
Okay, if you can click on. So again, these might just all look like yellow leaves, and what we're trying to show here is how do you get your eye in that, you know, in permaculture, observe. So these are sort of really getting a fine grain observation on the differences of yellowing in leaves and what that might be saying. So here we have, from the left, you've got the old leaves, to the right, you've got the younger leaves. And, oh, great. Is that getting bigger for all of you as well?
Yeah. Yeah.
Oh, fantastic. Thanks, Steve. This is a new bit of technology. Okay, so what we've got here is young leaves are yellow, old leaves are green, but you'll see in the middle there, and apologies, it's not the best example, but the veins are still green. I think this is a really, really common problem in citrus. You get green veins and yellowing pretty much across the rest of the leaf. And what that represents is an iron deficiency. Now, if you remember back to the graph, the chart right at the beginning, it showed that if you don't remember, basically iron is not available in acidic soils, and neither is calcium. And we're going to show you an example of that out in the garden. So all these things don't necessarily come in on their own, nice and neat, easy to see. So we'll show you some combos in real life when we go out into the garden. So this is young to old, yellow to green, and the veins remaining green. Okay. Thanks.
So how do
yeah,
you
click
get
back on.
iron deficiency in your soil fixed?
Acid soils, it's really common for acid soils to cause a deficiency. And what people would often do, you go to Bunnings, you get iron chelate, and you apply that to the leaf or the soil. But, sorry, that was the context around the acidity. We're always looking at what can you do ahead of just plugging a gap. And, you know, so ecological solutions, we do ahead of a one-off sort of silver bullet type solution. But here is something that's actually kind of in the middle. You know, an acid soil is locking up all sorts of nutrients. So by sweetening the soil with lime, you would actually change the soil environment for all those different minerals and actually release them. And that might be the sort of short-term, much better of the evils, to put in a little bit of lime, relatively simple compound. It's not, if you're not applying massive doses, it's not damaging to the soil biology, but it changes the environment for all those nutrients. Okay, so this one.
Julian, sorry, did you just say put in a bit of lime or put in a bit of iron?
Lime. Yeah, so the
even
lime.
though it's iron deficiency, you put lime in?
Yeah, sorry. There's a bit of assumed knowledge. Thank you so much for asking the question. Lime sweetens the soil. So you'll often hear that, it sweetens the soil. It actually reduces acidity. So if you remember the chart, if you make the soil less acid, then all the iron that's actually just locked up in the soil because it's acid becomes available. So you'll actually release iron by making the soil sweeter. And that's what that original chart was all about. And you'll not only release iron, but you'll release calcium, you'll release nitrogen, you'll release phosphorus. All these things that people are putting into the soils because they're saying that the leaves are saying that the plant's not getting enough of. If the soil's acid, it'll just be locking up all those things that you're adding. So a pH test kit, super cheap, is really worth getting just to see is acidity a problem. We'll also go into an example later, which is actually just temperature dependent. Again, you don't need to do anything. So we'll come to that pretty soon. Does that answer your question, Nikki? Yep. Oh, cool, thanks. I can't see you guys, but Steve's let me know you're nodding. Okay, on to the next one. Look at this. Oops, potassium. This is a potassium deficient showing leaf. What we've got here, the difference to hook your eye in, is that the yellowing is starting at the tip and working its way back towards the stem. And also it's very veiny still and patchy. Veiny and patchy and starting at the tip. So this is a potassium deficiency. That's what it's telling us. Again, there's a chemical that you can add. And again, diversity, compost will all, you know, over time, bananas, yes, of course, banana skins, rich in potassium. And obviously we've got them at home. Okay, on to the next one. We'll move through these a little bit quicker because it's really just showing what we're trying to get our eye into rather than you actually remembering these. Because you can refer back to and download that plant deficiency guide at any time and use that. Okay, what we're seeing here is the veins are still, it's still very veiny. But what we're seeing here is it's patchy. Yellow patches throughout the leaf, including right down the bottom. So that's the difference that we're seeing here. And that's a manganese deficiency. And I always, despite having a degree in chemistry, always confuse manganese with magnesium. Okay. Again, you can simply get a chemical or you can take the ecological approach. Anything simple for manganese? No, no banana skins. No banana skin cure for that one. Okay, and then on to our last one before we break out, magnesium. You can see here that it's also starting from the tip, like it was with potassium. But the thing that distinguishes this from potassium is it's not veiny. It's starting from the tip, but not veiny. And a really distinct triangle. That's clear sign of magnesium deficiency. Now, magnesium is in Epsom salts. So, you know, you have that at home. It's pretty simple, but that is still taking a plug the gap approach. And Steve, what's the nice solution for magnesium deficiency?
My understanding, I've been told, is that soil temperature has a lot to do with the availability of magnesium. So if you just wait till spring and wait for the soil to warm up, then your leaves will go green again.
Yeah, the do nothing and wait approach. Yeah. Okay, so here's a picture example showing a combo effect. So Steve, if you can click right. Oh, I've got to get you ready for it. Yeah, okay. There we go. Wow. Okay, so things don't necessarily come in ones, especially if we're talking about acidity problem. We'll have many deficiencies happening at the same time. So this is an iron and magnesium deficiency. The way you can tell that is iron. It's in the young leaves, not the old leaves. This one doesn't quite show that. Apologies. And with magnesium, you can see it's the deficiency. Oh, and iron also has the veininess. Iron also has the veininess, which might make you think it's manganese or potassium, but it's got the starting at the tip going through to the back, darker within that one leaf. So you've got two effects happening, overlapping. So just be aware. It may not be a simple single deficiency. So to give you a chance to digest, we're going to go into the groups, and ideally, each of you has a leaf that you might be able to show up and try and get the group brains trust to use this chart and what we've just heard there to try and diagnose it. So it's a chance to think about what you've heard and apply it to your own situation. If you don't have a leaf, no sweat. Maybe just Google that guide and just think out loud with the other people there to go through, and maybe in your mind, or things that you have seen, and just go through trying to use this chart to interpret what's going on outside. We will put you into groups of 3 or 4.
Julian, can I just ask a quick question then, Steve?
Yes.
Does deficiency always show up as red? Always as yellow and not red? Or are there variations in colour?
Yellow is the most common deficiency, but discoloration. But yeah, there are others as well. For the sake of this workshop, we've stuck to the simple plant one. But you'll see when you Google plant deficiency guide, there's ones that very detailed and complex. And sometimes red might be actually a disease.
Thank you.
Rust or something like that. But yeah,
Right.
And of course, stunting of leaves. We've mostly talked about yellow here. These are the really common ones. But gnarling of leaves, getting holes in leaves that aren't due to pest, browning off of leaves can also occur too.
Thanks.
Yeah, so make sure we're just about ready with the breakout rooms. Make sure that everyone gets a turn. There will be a timer in the top right-hand, well, for you, that'll be that way, top right-hand corner of your screen. So make sure everyone gets, roughly equal time. And we'll see you in the garden on the other side. Cheers. Yeah, let's turn recording off. Oh, so clever. And then,
Yeah, I couldn't.
yeah. Scroll down to breakout room. Okay, so where's the admin computer? Okay, thank you for the remark. Can you turn recording off? Or just pause, actually. There we go. Hello, is everyone back? Looks
Give
like
us a wave if you're back. Yep.
Yes.
Yep.
Are you guys getting feedback loops, or is it just me?
No. There we go.
Okay. Is there any
You're a bit,
formal feedback from each group?
Sorry,
you're a
what was
bit
that?
noisy because you're in with the kids.
Oh, of course.
Sorry.
Sorry, everyone. Okay. Well, what we might do is let's come over here. Go Beth. But I guess yeah. Is there what did people find? Would somebody like to report back from each group just a little? You know, what did they discover from doing that?
Maybe the first group. Oh, that's the first group.
Yeah. Do you remember the name?
Sorry. How about?
Can somebody jump forward from a group? Get the ball rolling.
Hi, Amanda here.
Thanks.
We had a couple of leaves from our group. One was a completely yellow house plant leaf, and another one was like a broccoli that I brought into the group that was full of holes and has been eaten by whatever, caterpillars. So we talked about how often you should be composting different things, and I think I learned that maybe I'm not putting enough compost on my broccolis.
Okay, great. Somebody from another group jump in, please.
Well, we were a little bit baffled with our one of ours, which just had just a big round sort of burnt-looking hole that didn't really tally with anything we knew.
Sorry, that was a little bit hard to hear.
One of our leaves just had a big kind of round burnt-looking hole.
Ah, okay.
So we weren't sure what it was, if chemical, something had dropped on it, or if it was some insect eating it. We didn't know.
Yeah, and wasn't covered in what we looked at this morning. But yeah, I guess more research to see what that's saying. And but you're welcome to send us in a photo if you want us to have a look at it too. We'll give it a stab. Okay, from one of the other last two groups.
From our group, it was also a little bit difficult to identify the deficiency in the soil from the picture that I brought. I shared my screen. And so one of the suggestions was to actually do a pH test on the soil and go from there, because it was a little bit difficult to decipher. And
Yeah.
the other picture was seemed to be a millibug. And so there were some suggestions about how one could address that from an ecological point of view. So that was interesting.
Yeah, great. Okay. And somebody from the last group.
Well, Kat had a really good leaf as well, but these ones were quite simple. We thought that this was magnesium, and to wait for the soil to warm up and fix it. But Kat, you had an interesting one as well.
Yeah, I had this one. So we suspect it might be a potassium deficiency. Yeah, I think that it just we need some banana skins or some potassium phosphate just to fix it. It's on my citrus tree, so.
Yeah, great. Okay. Well, look, we're going to have to go close to the preschool for just a second, because what we wanted to do is show you some of these deficiencies. Pick a leaf?
That'd be easier.
Yeah, it would be easier. I don't know. Well, I'll talk loudly because it's right next to you, so sorry. But yeah, we're going to go to 3 plants and show it actually happening on real plants, and that provide a reasonable demonstration value. Here we go. So for those who have been in the permaculture garden, we're against the preschool fence where the espaliered area is, and you'll see here, thanks Bart, a leaf here. Let's see. Okay, so that's almost textbook, right?
Yeah.
What do you reckon? So it's yellowing from the tip. It's got the, it's veined, and it's in the older leaves. Anyone want to hazard a guess?
It is a potassium and iron deficiency.
Sorry, too many.
I think it's a potassium and iron deficiency.
Okay. Worth thinking. Any other suggestions?
Oh, I thought it was magnesium.
Yeah, we think it's magnesium too.
Okay, good.
Particularly because of the dark down towards the base. Okay, now we're going to head over here. And we're actually going to a citrus that we don't often see. We don't often look at while we're in the garden. And this one's quite a good one because this one shows 2, and 2 different ones to the other ones in the garden. So here we are. We have got. Let's look at the young leaves. Can you see the young leaves? And they're really quite misshapen. We've got all sorts of deformities going on. What would that suggest?
Is it a citrus leaf minor?
It could, but there's no. If we come back up here, where's a really nice? There's a nicely deformed leaf. If you'll see underneath, there isn't actually evidence of citrus leaf minor going on. So it doesn't have the tunnels that they make under the leaf skin.
Okay.
It's just deformed.
Was it iron deficiency for the leaves at the top? I can't remember.
Yeah, so, okay, so it's in the young leaves.
Yes.
If you look at the older leaves, it doesn't have the deficiencies. So this is calcium. This is a really clear calcium one. But if we remember, calcium, back to the pH chart, calcium deficiency is very often linked to acid soil.
Yes.
And acid soils often also go along with an iron deficiency.
Right.
And if we look over here, where's it got to? Here, these leaves. Okay, so if you look at the old leaf, beautifully green, no sweat. Come to the young leaf, there. Can you see how it's all veiny? And it's evenly veiny from top to bottom.
Yes.
And actually, do you guys mind muting while it's just in between, just because it goes across to everyone? Your shadows on it.
Yeah, I know. Yeah.
Okay, so yeah, it's veiny and across top to bottom and in the young leaves. So that's classic iron deficiency. And that makes sense. We've got calcium deficiency and iron deficiency happening in the same plant, and probably because it's quite possible that it's a bit acid here. So what we might do next time we're in the garden is let's get out the little pH kits and do a test here and confirm that picture. And then, of course, it's back to what would we do? What we do with that. It's unlikely that we're going to buy iron chelates.
So eggshells.
Eggshells for the calcium. and you know, we'd probably add compost, which over time would slowly sweeten the soil as well.
Yeah, I think a really rich living ecosystem, really diverse living ecosystem, it tends to balance out the pH towards neutral over time as well. So yeah, the longer term, got a really good solution.
Would you put lime?
Yes?
Would you put lime in it?
Look, you could put lime. I think what we, you know, because we are a demonstration garden as well, we would probably tend towards the slower approach, and you know, doing that evening out, as Steve just mentioned, just to show that that approach does work, but it might take longer. Okay, so our last one, because I know we're just about on the 1 hour, and we're going to have to jump into the garden here. Okay, so here we go. This tree also has two different things going on. Here we go. There's one leaf. So, okay, these are the older leaves, not the younger leaves. The yellowing is starting at the tip and heading down towards the stem, and it's a bit veiny. What would you think this one is?
Is that potassium?
Potassium.
Yeah. Yep, we reckon it's potassium. Now, also, if we have a look a bit higher up at these leaves, drop that. Okay, let's try that. Yep, if you can turn it around. So, just, yep, that's it. Great, thank you. This leaf, it's an old leaf, not a young leaf, and it's got spotty yellows. What would you think that is? Somebody want to jump in?
Is that also potassium?
I'm thinking it's probably more, manganese.
Oh, manganese.
Yeah, because it's spotty, and it's not distinctly coming from the tip towards the back, and it's not. It's yeah, so it's this sort of spotty look of yellow, and that's why I'm thinking it's manganese.
I lost the video. I lost the video for a little bit. What did you say to use for a manganese deficiency, please?
So there will be a chemical from Bunnings that you can use. I'm not sure what the name of the chemical for manganese is. It's not one that I've. Steve and I laugh a little bit because that's not our expertise at all, because we take the other approach. Generally speaking, we don't get the chemicals. But if you say, okay, I've got manganese, you could go to Bunnings and ask for the chemical that helps with that. And yeah, let's.
So do you say does compost fix everything?
Thanks. So can you hear, Steve? No. The question is, does compost fix everything? Is it the magic bullet?
No,
thanks.
I don't know. I'm tempted to say yes, but I don't know. It certainly helps. It's part of the system. I think in the context of what Julian was saying earlier around how your plants exude nutrients into the ground, and then that feeds the organisms in the soil, and they then provide other nutrients to your plant, maybe too much compost is not necessarily good, because you're providing all the nutrients from an external source, and it could be disrupting that cycle. So 6 months ago I would have said yes. Today I'd say maybe not, maybe it is, it's not. Yeah,
so Steve,
diversity certainly is the
diversity.
So Steve, what about chicken manure, cow manure and horse manure? Are they good additional, you know?
I think the same thing. I think all of those additives that come from elsewhere, they have benefits, but there could be another side of them in the bigger picture context of what you're trying to create. And if you're trying to create, you know, a self-sustaining, really dynamic, rich, healthy ecosystem, they may disrupt that process as well. But I think it's all about balance and understanding. You know, if you're adding manure, you're adding nutrients. That may or may not be a problem. You're certainly adding microorganisms, which is a fantastic thing, because there's you know, chicken manure, cow manure, horse manure all have different organisms living in them. But yeah, I think
because in nature that would have happened back in the day, wouldn't it?
Yeah, well, in a natural ecosystem, you've got animals, and animals are adding manure. So,
however, they would have done it on a crash basis.
Yeah, they'd be adding 100 mil deep of manure at once. So maybe that's it. It's a little bit here and there is better than a lot one thing, and maybe that includes compost.
Yeah.
But I think certainly the key theme, and we'll say it again and again. Yeah,
we will.
Okay, I won't say it again.
No, not today. The D word.
The D word.
Yeah.
Hey, Amanda here. I just wondered why, if you've got acidic soils, why you don't get deficiency then of everything? Like, why is it that only one or two things kind of come up?
Good question.
Good question. You know, I guess it's difficult to say as a general thing. It could be that one way of looking, it could be that the bacteria that provide those other things are still providing to the plant. It could be that there's just more of that mineral in the soil than the other ones, and so some things become deficient first. It's hard to say. And of course, some minerals actually become more available in acidic soils. It's not all of them become locked up in acidic soils. If you go back to that chart, you'll see what I mean there. And you know, Australian plants take advantage of that. And so,
it probably depends how acidic, and maybe those temperature comes into play. I think all of these things, they come back to the idea that it's actually really complex. You know, this is a complex thing we're dealing with, and when you start looking at the ecosystem, you realize that. And maybe some of our solutions are just a little bit too simple. You know, it's missing iron, put some iron in the soil. Maybe it doesn't quite cut it. I think there's a more nuanced and sophisticated approach that actually is better in the long term and in the big picture.
I agree. Any last pressing questions? Because I think we're over time. We're over time. Oh dear.
Yeah.
So we might leave it there, but I hope you enjoyed that, and thanks for bearing with both of us as we settled into new shoes for today anyway. Yeah, so I hope that was useful for you. Let's see. Next week is immediate actions in relation to pest management. Back to Steve. He'll be presenting.
Yeah, so kind of trying to tie up this whole pest management thing. We'll look at a bit of a process that you guys can follow in your garden for pest management. We've covered a couple of the big ones in the last couple of weeks, so that ecosystem model and soil and reading your plants. There are a couple of the key first things that you might do for pest management, and then we'll go through a whole list of other things that you can do, hopefully answer a lot of your questions as well.
Great.
Cool.
Thank you. Thanks very much, Steve and Julian. Bye.
Thanks, everyone.
Thanks, guys. Have a good week.
Bye-bye.
Thanks
Thanks very much, everyone.
Thank you. Thank you. Thanks, everyone.